Good afternoon. My name is Rob Young with LITHKO Contracting QCM. I'm based out of Nashville, Tennessee. The good thing about what I do for a living is we are so spread out across the country, and everything we're seeing is regional and specific. A lot of things that I do for a living, I'm going to tell you, like you've heard for the last few minutes, is we try to plan ahead and get things organized before the job starts. Usually what ends up happening, and as we talked about kind of my part of this, I really want to be the guy that plans ahead and make sure the processes are installed before we start, and usually it ends up that I end up being the firefighter on dumpster fires and the like. So as we move through this process, the bigger portion of my presentation was based off what was asked for me in Boston, and the question was, what are you doing specifically to change the materials and methods and different kinds of things like that? So you're not going to see any graphs. You're not going to see chemical equations and stuff like that. Notice that just says Rob Young over there. It doesn't say PE, PQ, P nothing. It just says Rob Young, and that's why I like to keep it. So there'll be, we won't go over everybody's heads on this one. So what I like to do is, like I said, start in the beginning. Is that off center though? Why is that? Oh, okay. So we're going to get in briefly. I know this has kind of been beat in, but these three things are super critical to what we do. I think Joe left earlier, maybe still in here. Specifications, the 1L mill cert for us, and test pours. I need you to guys kind of follow me with these real quick, because as we get into the field issues that aren't any LITHKO jobs, we'll actually be able to kind of walk through some of this stuff. So, as Joe brought up earlier, we're still seeing less than 5% of y'all producing specifications written for our job sites that actually include 1L even mentioned of any type, shape, or form. And unfortunately, what that says to me as a general contractor is you don't know that it requires 2 to 4 gallons of additional water per yard. The water cement ratio on a 4,000, I cannot handle at a 4.2, and we'll see why. We're going to get into some of those other problems, not from LITHKO jobs. But the big force with this is that everything we're seeing, the set times and all that duration, is coming off of engineers not understanding what we're putting down as a product. And I'll talk more about that when we go into the test pours. This is a big problem for us. Unfortunately, this is yours, I'm sorry. But the issue date, the manufacturer date, the blend, and percent content. As you can see on this was issued to me on May of 2023. It's April of 23. Now then, that's not April 2nd, that's not April 5th, that's April, the month of April. So that 10L, I think that's a 10 up there, is actually for a blend of every sample that they've taken for the entire month. And I get the other side of that. The 457s, we've talked about that. Understand what I do for a living. I do get in the field. Usually I'm not this good looking. And with my guys, what I explain to them is this. It's hydration is what y'all call it. What we call it soaking in. And so take a handful of sand in one hand and baby powder in the other, and you shove it down in a bucket of water and you pull both out. Sand sopping wet, baby powder's dry in the middle. That's how that blend affects our finishers in the field. That delayed time to set, we're going to get into see why that's such a critical issue for us, is super critical. The second part of this is that 5 to 15%. As that runs through, what that means is that's acceptable to come to us, and at some point that average ends a 10L. What we see in a variance, I know there's been a lot of studies about how we're getting variance in the field. After Boston, I went home to a lot of my suppliers and encouraged them to start taking pint jars of every port. We have been financially impacted by several high limestone content pours. So with that, we're able to go back and say we had high limestone, or as we say, evaluate back through the mixed designs. Strategies has their own plants on a lot of their jobs. Mike and I work a lot together with our producers. We give them specific specifications for characteristics that we want to see in a field. We're going 44 floors up. I'm truck dumping, I'm bucketing on these columns and all that stuff. And so those are things that we communicate. I do rely heavily on the NRMCA sheet. I think it's a good one. I know that Strategies has got a great one, and we've paired up in the past on a couple of jobs. That's wonderful. I've read through it. So talk to Kyle. That's a great sheet. So the test pours. The reason why the test pour is so critical is because we feel like a lot of times we're going against the stream. When we see that, we see a 1-2 test pour, or we have to see a 1-2 spec. So everything that I'm now doing is on the 1L. So with that is shrinkage, is curling, is everything, every constituent of that to include their design. You know, when the floor cracks, I get the call. Then I call Mike. But you see what I'm saying? So every part of that design is super critical. Notice we're starting at this as deep as the subgrade and sub-base materials. If we're putting poly underneath it, that friction's big to that design. We have to test it. And you've given me a spec that says 1-2, and I'm using 1L, and it reacts differently to everything on that sheet. Our densifiers, our curing methods, the strike to grade method, how we're vibrating it, how we're rotting it, if I'm using a large laser screed, the reinforcement, the type of reinforcement. Does it require reinforcement? Everything is super critical in the design. So not only do you do the test boards, they have to be exactly the way we're doing it. Another thing we need to consider on these test designs, and I know that Kyle hit on this earlier, is that when I do them, I try to rip that slab apart. And so on that shrinkage with this 1L and that hydration rate, I would rather see a 20 by 200 than I would be a 5 by 5 or 10 by 10. And the reason why is because I can truly measure what's going on. The second thing I'm doing in that 200-foot long test pour is I'm testing variances in the mix designs. Variances in it. So sometimes we'll do a VE evaluation for an engineer and say, hey, why don't we consider flipping over to, say, a fiber slab from a rebar reinforced slab. That'll be one of my test boards. If I'm doing something on densifiers, if we're dry shaking, whatever it might be, we do those before we start testing the pours. But understand, it needs to be exactly what we're putting down because the 1L specs aren't clear a lot of times in our jobs. And so you need to test and prove to the designers that we can survive and get good results with a higher water cement ratio on a 4,000, probably in the 4.5, 4.7 range is probably lower end and as high as the 5.0s. Next. Keep all that in mind. Keep everything y'all have heard for the last 2 hours in mind as we run through these, okay? There are kind of some nasty things, and I promise we'll get through them though. All right. So I got called in on a job site, pre-con meeting, having a lot of them actually, and this was with the polisher. Usually LITHKO does a lot of structural concrete. We don't do a lot of architectural concrete. So when I get a spec, my guys immediately call me, hey, we need you to go talk to this guy. What went through, and he brought this up, was weak finishes. Ghosting is what we call it, raveling in the saw cuts, all kinds of real things. And everything I kept hearing out of his mouth was finisher, 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 right? We're throwing water on it. We're not finishing it tight. We're not hard troweling it steel in. And in all actuality, you know, I started just kind of giving that a lot of thought, and I walked out of that meeting with a lot of insight and came back to it. This was the next job I had called, and they said, Rob, man, this floor's got trowel marks all in it. Finishers in here? A couple finishers? So look at that, and you can tell how small that is. Our machines don't have blades that small on them, or a radius that runs like that. And it was kind of, I was like, and you guys know, man, we walked an edger down the damn thing. Well, not in a double. So come to find out, this customer, the end user of this building, started scrubbing that floor within 24 hours with soap and a rod and scrub machine. And those are the bristle marks of that scrubber on that soft surface that I doubted that polisher that I actually have. This is kind of some of the results we're seeing with that. Next, we're still seeing a lot of crazing, even with densification. It seems like that they're okay, and as the days and weeks go on, we start really noticing this is about 6 weeks later into this project. That 1L, whether or not it's a 1L or the reaction with our densifiers or whatever it is, it's kind of like they're late appearing. This is pretty small, guys. I'd say those are half a dime size, but it's just a whole floor like a shattered piece of glass. All right, anybody need a... Oof. So, as we go through with y'all's designs and we start working through the processes, everybody in this room is trying to get to the 2050 carbon, and y'all are doing things to help us out and to keep this as money efficient as we can and gets good results. We're seeing these structural fractures in these slabs. And as we go through and evaluate with this one, you can see the saw cut's pretty clean. It's not raveled out. But what happened on this one is this. We get these design and modifications. And so one of the things that was attempt on this one, in my area, we use a lot of river sand, almost explicitly river sand. And to kind of stretch out the dollars in the budget, this was about a 30% replacement with man sand. We already know, back to specifications and the discussions, that the 1L is thirsty, and now I've got an ag that needs more water in it. They didn't adjust the mix design. We ended up soaking it up, and it absorbed all the water and hydration out of it, and we ended up with structural fractures. Rob Young, Redneck Engineer, says that appeared early in our finishers and our pans, of course, finished it off. We didn't know about it, and then after we set, and obviously it's got enough cure on it, that they actually went through and showed their heads at a later time once it actually ran through the days. Back to the 1-2 plug, or 308 plug, I'm sorry. From the very beginning, guys, you have to control the moisture. Evaporators, as we're going through with the mixes, or at the finishing processes, finishing aids, we'll get into some of that at the bottom. There's some good people in this room that will answer your questions later, but cure, keep the water in, keep the water in, keep the water in. I told y'all. Let me stop right here. For y'all that know, that's Chris Toll. The one thing, I haven't been with 1L a long time, the one thing I can say about 1L is every one of these situations and problems, I've called somebody from ACI. 100% of the connection. So if you're new here, meet and greet, find new people, because all this stuff is where I've learned the most. So I get a call about this. So we have a quite significant amount of ag pop and honeycomb, pretty excessive. Can you come look at it? So, of course, I get on the road. So the first thing we did, I called a buddy of mine, and he went through and basically worked the mix design. We put a mid-range or mid-grade ag in it. We pulled the high range. This team was using a high-range water reducer. We went to a VMA on it, and as you can see, we kind of tightened up the mix. For those that can tell, finisher buddies, you're probably looking at about a 6 there at the pump, and we were probably getting about a 5 to 5 1/4, 5 1/2 at the tip. The next thing you'll see in this picture is what we call a wall snake. It segregates as it gets bounced through these horizontal forms and rebar. That's super critical to be shoving down in that wall and dropping it. ACI says about 3 feet. We'd like to see that stay. The second thing is the vibrations, and we're going to get into that in a second. A buddy of mine reached out once again, an ACI friend. But as we went through this design, what happens is this. This team was using a wall rattler on this job, which is an external vibrator, if you guys aren't familiar with that. And so what happens is it's a high frequency. It's probably between 10 and 15,000 VBMs. With the 1Ls, because that hydration rate is so much slower, it has available water. Paul's in here somewhere with 309. There's my buddy Paul. So first phone call, I seen the pictures of the honeycomb, and he said, I'll stash those with other 10,000 that I have, Rob, and you're over vibrating the concrete. What happens, guys, is this. We shove those vibrators down that wall, and if we're walking them up, that free water that's associated, because the concrete hasn't hydrated completely and soaked it up from the finisher term again, and it comes down the walls, and it forms into water columns, and it finds any hole that it can leak out. So it's either at the bottom wall. For y'all that don't know, that's a form line in there, so it's leaking out of that crack. Those are corners on the side and the crack there. Telltale sign. Oh gosh, let me see if I can point. See that halo? And that white, that's all water. So that hydration rate is very critical to us when we do these heavy, big walls. Slow down your VBMs on these. So what did we do on the verticals? And you can see here, once again, where the water settles at the bottom, washes out from underneath the form. Add that VMA in there. It moves the concrete. The guys get a good feel for it. It drops it. It kind of keeps it together as it drops through the rebar and the forms. Insist on a mid-range ag, like a 57s, and then add in either a 9 or a 7 blend at the bottom of it, using that wall snake. Don't drop it. Get it down there as close to the pour as we can and pull it up. about 4-foot lists is what we're doing. A lot of times when you talk to, say, a Miva, which was that former one of them, they'll give you how far you can lift. But understand, like Kyle was talking about earlier, a lot of their data is old data, and it's not really based on the hydration rate and how this tightens up. So the second side of this too is we really want to make sure that that slump is as low as we can get it, to get it pumped into the wall and placed. The second is drop down that VBM between 6,000 and 8,000. Internal, not wall. It's just like running a mag across it for you guys in here, the finishers. As you run that across there, that water comes right to the top, and as that form sits there and vibrates in there, it just ponds and settles. And close all form holes and gaps. All right, so moving into next thing. Once again, everybody's trying to help. So we've been having, early on with the structurals, we had a low break situation, I guess is the easiest way to say it. It's designers in the room. Where 1-2 would take off and just kind of keep this nice, easy climb. We've done good pours with everybody probably in this room, where even on a 7-day, we're even 100%, much less even second guessing a 75% break. It was to the point, I used to make pretty good money selling it high early, and, there before 1-2, it wouldn't need a consideration because the mixed designs, guys have done so well with them. So what's happening now, though, is because it kind of takes off in a 24-hour period, and then it kind of lays over slightly. It continues to climb, but it's a slower climb, or slower rate. And then to beginning, and a lot of the producers know this, we were fighting it to get it to full strength. And so what was ending up happening, we were getting a lot of design influence from the engineers, and then they were over designing the bars. And so they were basically offsetting the strength gain with rebar. Now let's go back to the 1-2 and understanding really what 1L is. So to get the shrinkage and everything else that's required in it, the large ag is required in a lot of our projects. And so what happens, though, is that we end up with significantly closer bars, and that's a design spec. And then what happens is I can't get 1.5 inch rock in a 3/4 inch hole. The second thing that happens, and we're building into some impact, so everybody keep adding, from that top flue to that metal deck to the top of that opening, it's 2 5/8 inch. For all you guys that don't have to take off your shoes here, that's a 3/4 inch chair. That's a number 6 bar, or 2 layers of number 6 and number 5s underneath. So I'm out of the concrete 1/2 inch already because we're trying to over design the openings. So when we do the design, it's not pounds of feet. When we get in the field, if I can't completely encompass and embed that steel, it is no function to any of us. So super critical. Just don't add bar to me. Make sure that we get a good, encompass around it with concrete. Second, PT. I don't know if everybody in here is familiar with this. These are heads on the edge of the wall, and what happens is we pour against them. That's a form. So that top thing kind of looks like a piece of unistrut is actually a mason's. They put a tie in it for you masons in there. Help me call what that is correctly. That styrofoam comes out of there, but that's in the edge of our form. So that's the edge of the slab in the building. We get in there and start pulling tension. So this team calls me and says, man, I'm trying to clean this up. These finishers, I speak quite a few languages. I consider, these finishers aren't vibrating these heads. For the third pour in a row, we're in here packing, we're backpacking heads. So as a QC manager, I made the executive decision that we're going to put a carpenter on the head and tail of every line. And if I had another one of these, that some people weren't going to be working for me the next day, and make sure they vibrated them. Now go back to my conversation with Paul. So here I got a finisher up there that's just grinding away because his job depends on that head being vibrated, and he's just vibrating and vibrating and vibrating. That's the deck bottom, and that's the form face. If you'll notice that ag underneath at the bottoms of the heads there, and the back where we've already chipped out at. So what happened is he created a wall or a mound of water that eventually leaked out. So similar project. So we're having testing issues. A lot of times timing's everything for a general contractor in the field. With the hydration rates being slow, the brakes being slow, we really depend on the mud being correct. It's part of our pre-construction phases we go through, and we give, you know, design criteria to our suppliers. And the biggest one for us is strength. We need 75% strength. With that being what it is, the field testing and everything with that kind of got a whack. We're seeing specs that don't require unit weight. And the next thing is the consolidation of the cylinders. A lot of times they're using the pencil rod cylinders in there, and we're ending up with smaller, lower brakes. So they went to maturity meters with the 5 tests and the 5 mixes. I'm sure everybody's familiar with that. The problem with that, go back to the 1L, is if they tested a 1L that was an 8L, and this mud comes out at a 15L, those maturity meters don't tell us what to do. So this is what happens. Look at the right side of that column. Guys go to lunch, we just stress cables. So all that comes together. What happened? Well, we probably got over-designed. We put a significant amount of rebar and tails down the side of it. We brought it together. So the resolution was to spread out the cables, redesign the engineering on the rebar spacing. We lowered the VPMs on it. Caution over the over vibrating, added the mid-range ag so we could get complete, you know, encompass of the cables and the like, and no retarders. We talked about that. That's a big thing that actually I can't compliment IMI enough. We've really been hammered the no retarders in the last couple of years. So quickly, pump location. This is our flat work. Pump location and quickly to the ground. We'd like to go at the tip. Make sure your testing's at the tip of the pump and not at the truck. We like about a 5 at the truck, or at the tip of the hose, 100 yards an hour. It's very critical with hydration to keep up that pace. We need that 100 an hour. Strike it to grade, float it off. And then we've added, on a lot of our ride and screeds, we've added actually where we can put a vapor retarder down as we go. Wait, delay panning. Wait. Don't trap the water, don't flood it in. It's going to take you about another hour and a half on most slabs, just so you know. Cure, then saw cut, don't saw cut, then cure. We're trying to do everything we can to keep as much water in that concrete throughout the entire process of it. We have had a lot of good faith and a lot of good tests and a lot of good hard work with the trout intensifiers. There's a lot of people in this room that do that. Talk to them. I'm not here to sell products, but we have seen significant reduction in crazing with the surface treatments. So quickly, we're in this together, as everybody keeps saying. Do those test pours. Make sure they are there. They have to prove what we've got in place is what the engineers want us to have. With just having a 1-2 and not the 1L specs out there, super critical. Get the word out. I can't be by myself. You know, I'm just that concrete guy that's going in and telling an engineer that he's wrong. But in all actuality, I fight it every day on water cement ratios and everything else, and it's because they're not keeping up. I need y'all's help. Evaluate your individual craft for practice, whether or not you're a tester, an engineer, concrete finisher, pump guys, everybody. Look at it. It's the little things that it attacks. Specifications, Blaine and limestone, super critical to us. Optimizing that mix design with those smaller ags and that hydration stabilizers, we get rid of those. And then fishing techniques, like we said, how we're putting it down is big critical to the mix design. Work with your installers. Hydration rate, consolidation of the equipment, keep those VPMs down. The timeline is lengthened, we know it. Additional products, intensifiers, and then of course expansive cements. We have done good products with that. And Kyle and those guys have covered that already. And like Kyle said, if you want to reach out to me, here's my email address. We have a pretty strict security policy, so probably burn most of them. But no, if y'all need me, let me know how I can help you. Thank you.